Hello everyone, my name is Blake Ludlow, and in this video I'll be talking about ammeters. Specifically, I'm going to briefly discuss the history and relevance. I'll define and discuss the governing principles of the ammeter, and I'll attempt to explain a short example of how one works and all the factors to it. But to begin, I'm going to talk about the history. Now, the history, the beginning of the ammeter, begins in 1820 with Hans Christian Ørsted, who essentially discovered that there was a relationship between electricity and magnetics. Now, he discovered this with just a wire with current going through it and a compass. He discovered that when you put a wire with current through it over a compass, it would actually cause the needle to deflect and point. So this, we'll talk about this relationship more on the next slide. But this also showed to him that there was potentially a way that you can measure the current in the wire. And this was a huge idea and huge concept because it would help just physics progress longer in this electromagnetics field. But it also, if you think about in today's society, that we need to be able to measure the current. If you think about power analysis or analog circuit design, we depend so heavily on this discovery. It's a huge thing. So I'm not going to spend a whole lot of time discussing the relevance as much as the principles behind how it works. Here, if we go on to the next slide, an ammeter is a device that can measure current, and there's two types. You have the analog ammeters and digital ammeters. Analog ammeters use the magnetic field and magnetic force produced by the current going through a wire to kind of measure the current, and that's kind of what Hans Ørsted discovered. He discovered that there was a relationship. But digital ammeters more so focus on, they have a small resistor that goes through them, and they got an analog to digital converter, and they can measure the voltage drop across that resistor and then measure the current through it. This doesn't rely too heavily on concepts that we talked about in 303, so I'm going to talk more about analog ammeters because they relate more closely to what we talked about in class. So going back to Hans Ørsted, he discovered that there was a relationship. But then once you have Biot came along, and he discovered or defined that relationship. He showed that the current could be related directly to a magnetic field, and then we know, like magnetic force, that magnetic field can be used to create a magnetic force. Now, if you understand these two principles right here, you understand how analog ammeters work. It's just manipulation of a magnetic field in order to create a force that you can use to move a needle or something that points towards kind of a scale. Like, for example, look at this next slide. Right here we have a scale. It's got a bunch of different values on it, and we've got a needle. So if we follow this needle down to the center, we see it's connected to this cylinder here, which is just a piece of metal, and it's got this around it. Now, it's kind of hard to see, but this is a coil. Whenever you would want to measure current, you'd hook up the terminals to either end of this wire, and it would cause the current flowing through that circuit to flow through this coil. Flowing through the coil, it creates a magnetic field, and the magnetic field will then polarize this piece of metal, creating a north pole here and a south pole here. Now, this specific ammeter is a permanent magnet ammeter, and so it's got a north pole here and a south pole over here. Now, what I said earlier, if there's a north pole that's been created by the magnetic field on this cylinder and a south pole on this side, what's actually going to happen is it's going to pivot or twist. It's going to cause this needle to point along to different values, and they have these springs here at the top and the bottom to restore and provide a resistance so that you can take multiple readings back to back, and it'll return to zero. But that's the fundamental concept, and you have the coil here to amplify that magnetic field so that you can get more force or whatnot. So again, it's really just the manipulation of that magnetic field in order to measure the current flowing through that wire. Now, this doesn't in any way affect the current flowing through the wire noticeably. It just allows you to amplify that magnetic field again and create a larger force. Now, if you understand that past slide, then you really understand how any ammeter could work. You've got various different models and ways they did it. They did some with gravity. They did some that would just use the magnetic field of Earth to return the the needle back to normal. But the concepts are the same. It's understanding Biot and then the magnetic field, the magnetic force formula. So, in conclusion, an ammeter is a device that can measure current. Hans Ørsted discovered the relationship. Biot defined the relationship, and then analog ammeters are just kind of the product of manipulating the magnetic field in order to measure that current. And so that's really all I have to say. I hope y'all learned something. Good luck on finals, and thank you for listening.